welcome! Today I would like to talk about one exciting PC which I bought a long time ago and was trying to repair all that time. It is a 486 multimedia PC made by Packard Bell. As you see, it is quite compact, probably 2/3 of the width and height of the standard desktop PC. Unfortunately, the front panel is very much yellowed, especially the CD-ROM drive, but with a little bit of retro brighting, this should be fixable. There is a warning sticker on top, which warns in German from freezing something in some industrial device, probably something what was connected to this PC in a German factory. This sticker will be, of course, removed later. Interesting is that the floppy drive is gray and not beige. First I thought that it was replaced, but I found some images online of this PC which also show the same gray floppy drive. So that came like that from the factory. On the back we have the PS2 mouse and keyboard ports, a VGA port, parallel and serial ports, and the power supply unit. This is obviously not standard, it is much smaller than a standard AT PSU. The fan is quite small and potentially noisy. Here is a sound card with a joystick port and 4 audio in and output ports. Packard Bell often relabeled as tag sound cards, and this is one of such. The exact model of this PC is PB486CD. Obviously PB stands for Packard Bell, 486 is the CPU type, and CD stands for CD-ROM drive, which was installed from factory. With that and the sound card, this model became multimedia PC. As far as I know, similar setups were made without the CD-ROM drive and the sound card as well. They were not named multimedia then, but otherwise they were the same. Now let's take a look inside. To open the case, you have to push up 2 blinds on the bottom of the front panel, where you can find the screws. One holder is unfortunately broken. 2 more screws have to be removed on the back. After that, 4 screws were removed. To remove the case cover, it has to be slid to the front. Yeah, as I said, one holder has to be glued. The first cool thing, as it was often made back in the days, a sticker with a short mainboard overview and jumper settings which is glued under the cover. This is super handy. Here you can see all the CPU settings, cache selection, frontside bus clock settings and schematics, where all those jumpers can be found on the board. Here we have a hard drive which is located on the side and can be easily replaced. If this one is still working, I'm curious which software we can find there. Well, as I said, Packard Bell often relabeled as tag sound cards in its systems, and this is one of such cards. And right away there is another very exciting detail. The CD-ROM drive which is connected to the sound card is a rare model. Such 40-pin ribbon cables were used to connect usual IDE drives, but in this case the sound card doesn't provide an IDE connector. It comes from the early days of the CD-ROM drives, and you can connect only proprietary Sony, Mitsumi and Panasonic drives to it. The cable goes to the Panasonic port, so despite that it uses the same 40-pin cable as it was used for the IDE drives, its pinout is incompatible to the standard IDE. I will come back to the CD-ROM drive later. Now let's take a closer look at the sound card. This red cable is a PC speaker pass-through, and it looks like the connector on the other end is broken. That is easy to fix. This white audio cable goes to the CD-ROM audio output. So, here is the sound card. As you see, there are Packard Bell stickers on the ICs. But let's take a look at the FCC ID, I38MMSN811. There is one nice page by Saxon Fox, where you can find a lot of interesting information about various Aztec sound cards. At this point, thank you very much to the author for this great overview. There you can search for the FCC ID, and this Packard Bell sound card is in reality a Sound Galaxy Nova 16 Extra. I don't want to peel off the stickers, but it has to be a sound card based on the IC AZT1605. It is a Sound Blaster Pro 2 compatible card extended with a wavetable header, which, by the way, a real Sound Blaster Pro 2 didn't have, and it provides indeed Mitsumi, Panasonic and Sony CD-ROM ports. This is actually a very nice sound card, which is not only fully compatible with the 8-bit Sound Blaster Pro 2 with a real Yamaha OPL3 FM synthesis, but it also gives us stereo 16-bit Windows sound system sound, which is implemented using this big Crystal CS4231 IC. There is a minor issue with this card though. It reports the DSP as version 2, which was used on the older Sound Blaster 2 and not Pro, which had DSP in version 3. Because of that, this sound card will be auto-detected as a mono Sound Blaster 2, but this can be worked around by setting Sound Blaster Pro 2 manually in the most games with such an option in the setup. The mainboard is very dusty. It is a good sign and means that the case probably hasn't been opened since the beginning. The installed CPU is an Intel 486SX33. It is quite slow and is a good candidate for an upgrade. One interesting observation here is that both memory slots are empty, as you see. This looks strange, especially because I assumed that this case was never opened and actually all parts should be in place. Well, remember this for later. The cache sockets are also empty. In combination with the very low-end CPU, it looks like Packard Bell tried to save every cent. No problem, I have some spare SRAM ICs for a decent upgrade. The video chip is a Cirrus Logic GD5428, a very compatible and fast video chip. At last for DOS it is my favorite, because it also works very well with TFT displays without vertical stripes, unlike many other video chips from that time. For DOS gaming, Cirrus Logic is my usual preference. For Windows, however, there are better options. Furthermore, this board provides only 1 MB of video memory with this 2x512K ICs, and for Windows it's better to have more, if you want to work with higher resolutions than 800 by 600 at 16 bits color. For 1024-768 you already would need 2 MB. And there are 2 extra slots for video memory expansion. But they are proprietary and I don't have such modules. Maybe a topic for a project in the future. The system has only 3 ICE expansion slots, however the graphics card and the I/O controllers are on board, so 3 expansion slots should be okay. 1 is already populated by sound cards, 2 more left for network and more. I think that the onboard Cirrus Logic VGA chip is bound to the CPU through VLB and is not limited by the low bandwidth of the isobus. Yeah, and there we go. I was afraid to see that. A leaky battery. The hard drive is a Conan 210 megabytes. I will come back later to it. And here comes the CD-ROM drive. It is Panasonic CR563B, a rare model which is quite expensive today. Correct me if I'm wrong, but as far as I know, it was used in the 3DO gaming consoles with its proprietary Panasonic interface. And a lot of people are hunting for it today because these drives were quite unreliable and need a replacement. It is an early and slow 2-speed CD-ROM drive, which was also distributed by Creative Labs in a bundle with the Sound Blaster Pro 2. By the way, 1 CD-ROM speed means 150 kilobytes per second, so 2 speed means 300 kilobytes per second. I could replace it with a much faster and more modern 52 times speed IDE drive, but I would be glad if this one is working and I could keep the system in its original state. The front is very much yellowed and needs to be retro brighted as well. The interesting thing is on the back. As you see, we don't have the usual master-slave cable select jumpers here, which can be found on the usual IDE drives, but there is device ID selection instead, similar as with SCSI devices. Here you can select IDs between 0 and 3. Currently it is set to 0. Right from it we have a 40-pin port, same as on usual IDE drives, but electrically incompatible. This drive should be connected to an IDE controller to avoid any potential damage. Another funny witness of the old times, the power switch. Unlike today with the ATX power supplies, where we have digital power switch, back then there was a physical main switch. On this machine the switch is directly on the PSU. And there is this plastic handle which goes all over the case to the front panel, where it is hidden behind the button. Okay, time to take a closer look at the mainboard. The chipset is a CC micro, and I think this is a premiere to me. I don't think that I ever have seen this chipset in person. Something new. What does the RetroWeb database says? Supports 32-bit 486 system design with cache and DRAM controllers, VESA local bus and integrated peripheral controller. Okay, looks like my assumption with the VLB graphics card could be true. Yeah, and left of it there is already a lot of oxidation. What a shame. As I already mentioned, there were no memory modules inserted into the slots, but this system looks untouched to me. So where's the memory? The cache sockets near the ISO slots are empty, as you see, but here we have a couple of ICs which do look like memory, and it is. Every chip looks to be a 4 megabit DRAM IC. With 8 chips we then should have 4 megabytes of onboard memory. This was plenty back in the days for a 486SX33 and explains why we don't have additional modules. And exactly, looking once again at the schematics, we see areas marked with SIM and DRAM. Would be cool if both memory types could be used simultaneously. But first we have to neutralize the electrolyte with white vinegar. If you are curious why I'm doing this, I made a video about it a long time ago. Now it's time to make someone nervous again. Let's wash the board using tap water and some soap. The good news is that the board is clean and dry again. The bad news is that the leaked battery made a lot of damage. There are a couple of damage traces which are even visible with a naked eye. Let's make a first test and try to power up the system. There seem to be no shorts on the power rails. I will connect the monitor just in case it will post, and we will also need a post analyzer card. And we see no numbers on the analyzer card. This board seems to be completely dead. At least the CPU gets warm. Just in case off camera I checked the jumpers, but they are all fine. As I said, I don't think that this PC was ever opened or modified, so that was expected. Okay, now let's check the CPU clock. On the 486 this is pin C3. I use a wire inserted directly into the socket. And we are getting 33 MHz, very nice. The next thing to check is if there is some activity on the address bus. For that purpose I use my ISA prototyping board with an angled ISA Razer card. This way it is very comfortable to check the various signals. And we have some activity on the address bus indeed, so the CPU is alive and something happens on the board as well. This is also a good sign. Also on the data bus there seems to be something as well. This means that the chipset is probably alive too. So I took a closer look at the traces around the battery and there was a lot of heavy damage in this area. Some traces were completely missing, but this is not the worst, because those were at least visible with the naked eye. There seem to be quite a lot of micro cracks which are not visible even with a magnifying glass. Some traces without continuity were running under the ICs, which didn't look well either. I had to remove the ICs to get to the traces underneath, and unfortunately, as I struggled to desolder the parts, I didn't notice that the battery in my camera got empty, so I didn't record that process. One issue with the heavily oxidized solder joints is that the solder doesn't melt anymore, it gets brittle and the oxidation destroys the solder pads as well. This is what unfortunately happened here. The solder pads turned out to be totally eaten away by the spilled over battery electrolyte. I also overheated the ICs trying to remove it, so I will need a replacement for that. But I'm more worried about the pads, and the good news is that there seem to be still enough solder pads left to hold the new ICs in place. These traces seem to have a lot of micro cracks, but with some polishing and hitting, maybe this can be fixed. Also, these traces are all destroyed. And this trace has even vanished partially. I will have to add a lot of jumper wires to get it all working again. I drew a schematics where I marked all the broken wires. Red means front side and blue is on the back. Some missing pads and traces have wires nearby, so for stability reasons wires can be soldered through them. However, those wires are still filled either with oxides or with solder mask, and I'll have to remove it somehow. As always, I cleaned the traces with a polishing tool until I got the shiny copper traces back. Those have to be tinned. Now to the wires. I bought this set of 0.3 mm tiny drill bits, which fit perfectly fine into the wires. They are very brittle and I broke the first one very fast, but with a lot of patience I could free the wires very well using it. After that, it was time to tin the traces and add wires on top. Of course, soldering wires on top of the traces was only possible in spots where the traces did at least partially exist. Restoring the pads is not an easy task, but luckily more than the half of the old pads were still there, so I decided just to use wires instead of pads. I decided not to use the old IC since I overheated it during removal, so I ordered some new replacements. This is a 74HC 151 multiplexer. The soldering is a bit tricky since there are no more flat pads and the IC shall be lying on top of the jumper wires instead, but soldering the IC did work fine. The real problem started as I was trying to fix the traces. They were very thin and there were a lot of micro cracks and I barely could see whether tinning was good enough and where I would need more jumper wires. I was trying to work with a lens and my camera, which has an impressive macro mode, but that turned out to be more tedious than I thought. So I decided to give a microscope a chance and went online to search for one. As I said in my last video, suddenly I got an offer to make a review of a microscope, which I happily accepted. And I was not disappointed. I thought that it would be hard to work by just looking onto the screen, but after some warm-up that turned out to be easier than I thought. Here I am forming and soldering a 0.3mm thin wire to an SOIC16 chip, where the distance between the pins is only about 1.2mm. I was really excited and surprised how well it went. Eventually I had to repair a lot of broken traces. Some could be fixed invisibly by enforcing them with a wire, others by putting external jumper wires, but all that work was still not enough. By the way, I also replaced the original Dallas RTC chip with a pin-compatible one from Benchmark, which I also use in my RTC modules, since Dallas was also heavily oxidized and I didn't really know if it is still working. After all the work, the board woke up to some extent and some numbers were visible in the post-analyzer card, but the initialization stopped at the error code 02 after 01. On a Word and later Phoenix biases, this usually means that the RTC fails to initialize, so I checked all the pins for continuity and again the microscope helped to find the culprit. As you see, probably due to the heavy oxidation, previously the pad didn't hold on the PCB anymore and lost its connection to the trace. First I tried to solve this using a blob of solder, but that didn't really help, so I enforced the connection with a piece of wire once again. And after that, you will not believe how happy I was as I saw postcodes running through on the analyzer and eventually the Packard Bell logo on the screen. What a relief! I was working on and off on this mainboard for about a month, trying to revive it. I even played with the idea to use another similar board in this machine which would fit, but I wanted to keep this computer as original as possible. And now we should hopefully be on the right way. At least this system is booting into DOS from the compact flash card. This is already a huge step forward, and in the next part I'm going to take care of the case, PSU, drives, build everything up, take a look at the hard drive which was installed in this machine. Who knows, maybe we will find something interesting there. I would also like to make some upgrades and hopefully end up with a very nice 486 gaming machine. I hope you enjoyed this video and would join me in the next part soon. So far, thank you and goodbye.